Yeah. Right. Okay. Acids and bases. Yes. Yes. So we do a little bit on acids and bases in year 10, 11, certainly for GCSE. Can anyone remember the definition of acids from GCSE days? It's a long time ago. Something to do with
H plus ions.
Yeah, H plus ions. That's right. So acids, we define them as proton donors. That's the explanation. Just to proton, it sounds like this, you get this sort of stream of protons coming out from an acid, but it's not quite how it is. Remember, a hydrogen atom is simply an electron, single electron, orbiting a single proton. That's it. That's what a hydrogen atom is. So a hydrogen ion, well, that means I remove the electron, so it's just a proton then. So for the work that we're going to be doing together on acids and bases, I'm going to use the term proton and hydrogen ion interchangeably, because they're the same thing. Protons are hydrogen ions. Hydrogen ions are protons. And when we say they're proton donors, that means that in any kind of solution or situation, they're able to release that proton and give it to somebody else. So if I put some hydrochloric acid into water, hydrochloric acid is a gas in its pure state. But if I dissolve that gas in water, it instantly breaks down into ions. Okay, so a couple of things. This idea, this definition of acids as proton donors is down to a couple of scientists called Bronsted-Lowry. So we say this is the Bronsted-Lowry definition of acids, that they're proton donors. There's another definition of acids, which is called the Lewis acids, which you will come to later in the year. It doesn't work around protons. So this is so in the exam, you'll get a very specific question. Give the Bronsted-Lowry definition of an acid. You'll say proton donor. We could also imagine that the HCl is reacting with water. So the H from the HCl the HCl gives its hydrogen ion, gives its proton to water. So that would make water H3O plus.
Hello, sorry to interrupt. You know the piece from The Economist?
Yes.
Do you say you were going to do some questions to go with it?
I'll put them on.
Have you put them on?
Satchel, but I only did that for this group. I
That's
think.
okay. I'll find it and I'll put it on for mine.
Okay.
Thank you.
Thanks. So we could imagine that the HCl gives its proton to water, hence proton donor. Donor implies that you're giving something. If you donate to charity, you're giving charity a quid, whatever. So the HCl is donating an H plus to water. In which case it would make that ion there, the H3O plus ion. It's called the hydronium ion. But that's not hugely important. The thing is that H plus ion wouldn't hang around on its own. H plus, proton, it's a very small, very highly charged particle. It would interact very strongly with all the water molecules and everything else that's in. So it wouldn't hang around on its own. But again, as far as chemists are concerned, these two equations are the same. They're interchangeable. HCl gives away its proton and leaves a chloride behind, or HCl forms a hydronium ion and a chloride. As far as I'm concerned, they're the same. And we're going to handle H plus and H3O plus as if they're the same thing. Does that make sense? Okay. All right. Let's just do the dissociation for a couple of other acids. So we've got HNO3 and H2SO4. Those are the other two common strong acids. Can you write the reaction equations for them? I've been using this expression break up into ions, but there's a better word for that. What was that?
Dissociate.
Okay, some other acids dissociating. Yeah. Dissociating. So we use that word dissociate, meaning to separate yourselves from maybe a group of people. Yeah. Somebody does something strange, you know, maybe some guy involved in football gives a woman in the team a kiss or something. I don't know, just making up something randomly. You might expect other people to dissociate from that person. They don't really want to have anything to do with them anymore. So of course acids don't just react on their own, they react usually with bases. So let's just remind ourselves about a few acid-base reactions. So there's some acids and bases there. So give me the products for each of those and make sure they're balanced. Yeah. All right. So yeah. So for sodium hydroxide, H2SO4, it's sodium sulfate, but we need to remember that it's 2 sodiums for every sulfate, 2 pluses for 2 minuses. And then the other product is water, and then balancing. Well, we'll need 2 sodium hydroxides and 2 waters. Yeah. Okay. So this is a slightly different acid, ethanoic acid. It's an organic acid, which is the proton that gets donated, released.
The H from the potassium hydroxide.
Well, that's the base.
Oh.
This is the acid, which is the H that it donates. So yeah, that's ethanoic acid, yeah? And it's that hydrogen there at the end that gets lost. So it makes CH3COO is the ion, or minus it would be. And then that teams up with the K in potassium, CH3 Cook, and then that makes water as well. Okay, so what about calcium hydroxide and nitric acid? What do we make there?
We could do Ca and then in brackets NO3, then a 2 after.
Yeah, so again, calcium has a 2+ charge because it's in group 2, whereas the nitrate ion is just -1. So when I'm writing calcium nitrate, I need to have 2 nitrates to cancel out the 2+ charge on the calcium, and then 2 waters again, isn't it?
Yep.
Oh, I was going to balance in orange. Yeah. And the last one. What's going on there?
Is the H's on either end swapped with the NA?
That's exactly right. Yeah.
So
So
it'd be 2 NA.
so it's 2 acid groups here attached together. It's a diacid. The hydrogens on the end both swap and get replaced with sodiums, and then we make water. Do we need 1 or 2? Surely we need 2.
Yeah.
2 sodium hydroxides, yeah, and 2 waters. Okay. All right, so most of our work in this topic is going to be focused around pH. What is pH and how do we calculate it? Might not be used to the idea of calculating pH. Usually when pH is introduced in year 7, it's almost like it's a colour. You know, the pH of acid is red. But pH is a number, and it's a calculated number, and it comes from a formula which we can state very easily. I know. So let's start at the end. Square brackets around H plus means
Concentration.
That was nice. That was everyone. Concentration of H plus. Okay, so that's the easy bit then. The log is usually a bit less familiar for people who have not been doing maths for the last year. What is a log?
Is it the exponent, or how you find the exponent?
Yeah, it is. It's the exponent. Yeah, we're in base 10 now in here, so sometimes you'll see a little 10 there, but we don't need it. It's just going to be assumed we're in base 10. Nobody generally works in base 5 or whatever. So the log of a number is the power that 10 is raised to, or the exponent that 10 is raised to. So if I have 0.01, I can express 0.01 as 10 to the minus 2. Okay, so log of 0.01 would be, well, 10 is being raised to the power of minus 2, so log of 0.01 would be minus 2. Of course, you don't really need to remember that. You just need to know which button on your calculator to press. As long as you can do that, you can do all the maths that you need to do. Okay, it's well, you know, at the end of the day, we're not mathematicians. You don't have to remember, you know, log A plus log B equals log A times B and all those kind of stuff you do. All of that is just maths. Your position is going to be to remember that formula, minus log concentration of H plus, and hit the right button on your calculator. So, let's assume a nice simple question. Calculate the pH of 0.1 mole per dm cubed HCl. Okay. calculate the pH of 0.1 mole per dm cubed HCl. Well, first, of course, it's not minus log concentration of HCl, is it? It's minus log concentration of H plus. So we have to know what the concentration of H plus is. But for a strong acid, we assume that all of the molecules of HCl dissociate into ions. So I'm just going to add another important statement. Strong acids completely dissociate. Strong acids completely dissociate. All of the molecules turn into ions. So if you were to get a beaker of hydrochloric acid and sort of peer into it with incredible molecular spectacles that enable you to see every individual particle in there, you wouldn't actually see any HCl's at all. You'd see water, and then you'd see H pluses and Cl minuses, or H3O pluses. You wouldn't see any HCl, because all of the HCl's are broken up into H pluses and Cl minuses. Now, that makes our calculation very easy. If all of the HCl's turn into H pluses, then if I had 0.1 mole of that, it'll break down into 0.1 mole of that and 0.1 mole of that. So in this case, the concentration of H plus is exactly the same as the concentration of the acid. By concentration of acid, I mean what's written on the bottle, or what's written in the question. So if the question is, what is the pH of 0.1 mole per dm cubed HCl, I can go 0.1 mole HCl, that's the same as 0.1 mole H plus. I can assume they're the same because it's completely dissociated. Okay. So we can now quickly get to the answer. pH is minus log of H plus, so pH would just be minus log of 0.1, which you can all work out for me on your handy calculating machines. It's not minus 1. Just 1. Which is kind of what you'd expect for a strong acid, right? pH are right down the end of the scale. pH of 1. You'll notice that I've added 0, 0 onto it. pH is unusual in that rather than doing the sig figs thing, pH does a decimal places thing. We're always going to express pH data to 2 decimal places. Always, always, always. And AQA usually put a thing in the top of their questions, express all pH data to 2 decimal places, to remind you.
Is there a unit or is it just 1?
No, there's no unit. Once you've logged something, units kind of get, well, I don't know what happens to them. They get logged as well. What's a log of a unit? I've no idea. And something similar happens to sig figs, right? If you log a number, the sig figs don't quite mean the same thing anymore. 3 sig figs don't sort of survive logaritmicizing, anyway, log taking, which is maybe why AQA have just gone, forget sig figs, let's just go for 2 decimal places for all pH data, so saves any kind of faffing looking at the question, what was the data in the question? No, just 2 decimal places. Okay. Let's do a couple of those, and then we'll do them backwards, and then we're done. when hydrochloric acid comes to us, it comes in big 2.5 litre bottles, and it comes with a concentration of 10 mole per dm cube. That's concentrated hydrochloric acid. Just do those for me, please. Come down.
Just be a bit more.
Does it?
Doesn't it?
Like half a degree. Nearly there.
Minus one.
28, 20, 29. Yeah. Yeah, that's right. So remember, pH is just a number. There's no real rules about numbers. Numbers can be anything they want. So again, H plus and acid will have the same concentration because all the HCl will be dissociated. So the pH will be minus log of 10. Log of 10 is 1. 10 to the power of 1 is 10. But it's minus log H plus. So it's minus 1. Don't forget the zeros. Yeah, so really, really strong acids can have a negative pH. That's fine.
When you put it in, you do minus log, or you log minus the number?
Minus.
No, you do log of the number, and then you change the sign afterwards.
Oh, I see.
Personally, I just log the number, so I don't get the minus in the wrong place. If you get the minus in the wrong place, it should error anyway. If you do log of minus 10,
Where
that doesn't work, does it?
Is it the same with H2SO4? Like
No, it's not the same with H2SO4.
With the pH, where does the 1 to 14 scale come in?
Well, 1 to 14 is what we tell GCSE
so
students
that's
because
simplification.
it's a simplification. Yeah.
So it's like that electron shield thing. It's like that's GCSE level.
Well, it's just because
Oh, shall
explaining why you can get a pH of minus 1 to year 9s would probably be. No, we don't want to do this. What's a log for a year 9? They've got no idea.
Yeah.
So, yeah.
Okay.
Right. So it's important for H2SO4 that we remember that there's a number 2 in the equation now. So because H2SO4 dissociates to make 2 H plus ions, the concentration of H plus now is 0.3. The number 2 is going to be very annoying in this topic. It's going to keep cropping up in little ways like that. So let's maybe make a note that H2SO4, you can see where they're going here. You know, the H2SO4 is going to be the one they ask the question about in the exam, right? Right, so pH, I don't know what log of 0.3 is.
0.52.
Hang on, is that minus?
No,
Which is no?
it's not mine.
It's not minus.
It should be
It's-
minus
it's
because it's
just
less than 10,
minus.
so it would be a negative log.
So it's
0.5.
0.2.
5,
2.
2 decimal places,
That is the 2
Yeah,
decimal
that
places.
5-2.
5, 2.
Yeah.
Yeah. It's weird with 2 decimal places because it means you know, for a low pH like that, we've got 2 sig figs. If the pH was like over 11, then you've got 4 sig figs. But it's just, again, it sort of makes it easier. Right, in the last 5 minutes, let's see if we can flip it. What is the concentration of HCl solution with a pH of 1.5? What is the concentration of an HCl solution with a pH of 1.5? In other words, how do I reverse that equation? How do I make H plus the subject of the equation there? I get a lot of antilogs at this point. There are no antilogs.
You use the E, don't you?
It's not E because it's not log to the base E. That's a natural log.
Okay.
But you're on the right lines. If you look at your calculator buttons, where you've got your log button, which is probably one of the main buttons on the main thing, yeah. Just above that, the shift function, it'll say, what does it say?
Small power.
10 to the power of. That's the opposite of log. 10 to the power of. So if I rearrange this equation, it would say H plus is 10 to the power of, and we mustn't forget the minus sign, minus pH. H plus is 10 to the power of minus pH. So again, if you use the shift log button on your calculator and put in minus 1.5,
.03.
0.03.
Yeah.
Is that right?
Yeah.
Okay. Any other sig figs on that, or is it exactly 0.03? Okay.
0.032.
Yeah.
3.2. And of course, we're back to mole per dm cubed now. Okay. All right. Make a start on exercise 1 for me. You should be able to have a go of questions 1, 2, 4 there.